Hello, Internet. Welcome to this presentation about my Kaggle project that I recently completed. In this video, my focus isn't on showcasing the code itself, but on walking you through the thought processes and procedures that I use to uncover meaningful insights from the data. So don't worry about the coding details. Everything is provided in the link displayed on the screen and in the description below for you to review at your own pace. Now, if you're ready, let's dive into the fascinating world of data exploration. Upon downloading the file from Kaggle and opening it with Excel, we find that there's 16 columns here. And by selecting a column, we could find that at the bottom, there's a count of 43,740 rows. We see combinations of numerical and categorical data. We see that the unique identifier will be order ID. So there's very kind of data we could look into. We find some numbers, integers, real numbers, and some GIS coordinates. GIS, which stands for Geographic Information System, and this can be used to find pinpoints locations. We have here date information. We have time information, categorical data in terms of weather, traffic, types of vehicles and areas, categories. And thing that we should look into is likely would be delivery time. But I could see from here that there's order time pickup, order time that was made. Sorry, so time that the order was made, or time that the order was picked up, and the time it took to deliver. So putting all these together, so we could derive total time, which would be a summation of everything here. Of course, we need to clean up the data to do more analysis, but the point I'm trying to make here is this. We're going to take this spreadsheet, which is just numbers and letters, but we're going to find useful information out of it. And that is the purpose of data analytics. Okay, so we're getting to the nitty gritty, and I've opened up the notebook. We're going to go quickly as possible. I will emphasize and slow down on things that are important, in my opinion. Now, first off, let's get started. We imported some necessary packages. We've loaded the data set. I've put the command .shape. This gives me an idea of how many rows and columns. So 43,739 rows, 16 columns. Data that describe would output all the numeric data. And we see here number of counts. Now we see a discrepancy here between the two numbers. So it's likely there's just some missing data here. Mean would be the average, standard deviation, minimum value, maximum value. And this gives me a quick idea and a quick overview of what the numbers look like here. So from that, I was able to derive that delivery ages range from 15 to 50 with an average of about 29. Agent ratings range from 1 to 6. Delivery time ranges from 10 to 270 minutes. Now, looking at this, there are some potential objectives that thought to my mind. Number one, we want to increase agent ratings. And number two is to lower delivery times. So with the combination of two, it's likely that these metrics would have an improvement in customer service. Continuing on, I did data.info to find out what data types exist. And looking at here, something that popped to my mind here is about this, that the order times and pickup times, which they were in objects. It's likely that we need to convert all of them into time to do time calculations. And I did a little experimentations, and it did turn out that they were indeed in strings in this kind of hour, minute, second format. So what I decided to do is to convert all of them into a standardized time format so that pickup times, order times, and delivery times could be used to find total time, for instance. The next section, I'm going to explain the data cleaning, and cleaning would be one of the most important steps, because without proper data cleaning processes, even with the right processes, you will not have the correct results. So the next section I'll undertake explaining that. The first thing I did was to check for null values. So this is the command I used. We found that there's two columns, agent rating and weather, which has about 54 and 91 respectively in terms of null values. I took a closer look. Of course, weather is categorical and agent rating is numerical. Now, there is a method, like since there's not a lot in terms of compared to 40,000 data points, there is an option to either just drop them or to fill the data. Now I took the challenge of filling the data here, numerical with the numerical data here, the agent rating. What I did is I replaced the missing values with mean values, since me having the mean values would mean it wouldn't change the entire column, the value, right? The next thing I did with categorical, the weather, I chose to do mode. Now, there are various different methodologies. It could get very complex, but for simplicity's sakes, for this experiment, I chose this simple route and I continued on. This is a code to handle the missing values. And then after I checked, and then one more check, and then all the missing values have been filled in accordingly. The next thing I've worked on was with the GIS, Geographic Information System data, with the longitude and latitude. I've noticed skimming the data that there were some points which were 0 and 0. Now I've looked into it. 0 0 refers to Null Island, which is a point in the middle of the ocean. That obviously does not make logical sense. So what I've decided to do is to filter that data, looking at how many of them exist. There's about 3,500 points. Of course, I had to take them out because we cannot. There's no way that a delivery point could start from the ocean, right? So we filtered them out, and then that this was the result. This is a piece of code I've noticed like while I was doing it. This popped up. Short way of rectifying it. I just put this command. I made a deep copy to continue on. Um, the next thing I've done is the order date. So this was in a string format, and I've underwent to make a conversion. So I used this command and found out that yes, it's indeed in string. So I converted to date time and then checked it that it was done in date time, and yes, that was the result. So they were all converted from string to date time formats. Now with delivery times, they're not dates, but they're times. So which is slightly different. So I took those columns and put an output, and they're not in uniform format here. So I've noticed that okay, it's like 15 minutes plus 120. So I knew that it's a sub addition that needs to be made to get total time. So this is the formula I derived from it. So that's this procedure I just took. I've noticed that like while trying to convert, there were some error messages, and there might have been some white spaces along the way. So I used this code to get rid of the white spaces, and then I converted them to time. I used time delta here, and then I used them for once it's converted, you could do formulations like this to do time calculations. It's automated, so you don't need to worry about getting actual getting numbers right. It'll do it for you. And then I just wanted to have uniform format, so delivery time is done here in minutes. So what I've decided to do is convert them into minutes as well. And then this was the results. So first one was about 15 minutes. So I knew this was correct. So I checked the first five to make sure the times outputted were correct, and they were indeed correct. So I kept moving on. So initially, I thought the data was clean, but then turns out that even with things that code was somewhat correct, the output was somewhat wasn't. Turns out that there were about 759 points which were negative. That didn't make sense because you cannot have negative time. My hypothesis was like maybe there were some orders that were done through midnight and that caused some miscalculations to happen. But regardless, for simplicity's sake, I just decided to take them out and filter them out. Um, so I've only chose times that were greater than 0, and then I was able to derive to total times. Use the command head to find out, the first few ones, and then make sure that all the calculations made were correct. And then I've been them. So the reason I did this was because initially, prior to cleaning like this, it was very skewed and didn't the data did not make sense. But through this output, I know it makes sense, and I could keep on going forward. The minimum delivery time was 15 minutes to about 285, like mentioned prior. Um, Initially, I did not realize this, but later on, I found out that the pickup times, right, they were not as significant. So just using delivery times would have been enough to do proper analysis. but I'll explain it in the later section. We arrived to the fun part, the actual analysis. Mind you that in the while I was doing the project, I had to go back and forth many times because as I was going, I noticed some inaccuracies and things that didn't make sense, and I had to go back and forth between data cleaning and the analysis because I had to keep on fine tuning. So it for me it wasn't a one go. If it's one go, you're very lucky, but it's likely that you'll need to go back and forth between data cleaning and analysis to fine tune things and correct things. Um, what I did here, the first thing I did is a correlation matrix. It gives you an outline of the correlation between the variables. And one thing I found out was this. I'm not going to explain correlation in too much detail, but just know that there are three observations that need to be noted. There's a strong negative correlation between agent rating and delivery time. Simply put, it meant that uh, when delivery times were shorter, it costs increases an agent rating. So there's a reverse relationship. That's called negative correlation. Number two is that there's a positive correlation between delivery time and agent age. So when higher the age, the likelihood of a higher delivery time, which is not helpful for case number one, right? Number three, I found out was that there's a moderate negative correlation between age and rating. So um, two and three sort of help each other out. Simply put, the conclusion is that younger drivers tend to do better than older. Now, I don't. That's what the data says, and we don't know exactly why, but that's what it says. We're going to keep on going to find out. Um, you can read this later at your own time if you wish, but I'm going to keep going. So here's an output of the um, agent rating plot. So what I did is I plotted the number of occurrences of not occurrence, sorry, densities of the scores, and we see that the average scores may be between maybe 4.5 and 5-ish. And the objective here is to push this towards the right. We want to increase, if you're a business here, we want to increase the agent rating because that likelihood means better customer service. Well, that's the implication, but not that was made here. Um, so let's get straight into the fun stuff now. So this is slightly different, but I've decided to look into sales data, sales analytics, and find okay, which there are some dates, right? Which month would be the one with the highest sales count? So I've group by them, the data sets, and then output it through the counts. Turns out that March is the month with the high sales. And with another question arise was there's different product categories, right? Is this just for one or many or all? And upon analysis, we found that indeed that all product categories, regardless of product categories, you'll have the highest number of sales at March, which is denoted here in orange. So I've mentioned about agent age, right? Now, if agent rate if age had no impact on the data, I would have likely have seen a perfect square in this graph here, but there's some missing data here. Now, we don't know if it's actually missing plots or so forth, but this is what we see, and I knew that I had to dig deeper. Now, upon digging deeper, I found that yes, there is seems to be a relationship between the agent age and delivery time. If you see here, agent age 20, the delivery average delivery time is 108 minutes. As higher the age, we find that it's 140, and we continually see this relationship all the way up to 50. And I could prove it to you by through this plot. Uh, and we found that yes, there is a relationship between agent age and delivery average delivery time. Higher the age means likelihood of a higher delivery time, and vice versa. And I wanted to see if that impacted rating as well. And yes, that is also the case that is found. Lower age drivers, they tend to have a higher rating. Let's say, for instance, age 20, you have an average rating of 4.68. 39, you have 4.57, which is lower. But let's plot it and see if that's the case. And that is indeed the case here. Seems like the 30 seems to be the cut line between the two, which halves the data here. But this is evident that age does seem to have an impact in agent rating. So the conclusion I was to derive was that faster delivery times led to higher agent ratings, that's for sure, and younger drivers tend to make faster deliveries. So, um, oh, there's one thing that popped in my mind. I'll have to do an analysis. Maybe is, do younger drivers have shorter or longer routes? For instance, you got to think critically here, right? If, let's say, for instance, all the older drivers took much longer routes, and the younger ones took the shortest, right? This could explain that. But from what I see, this is the conclusion that I derived. Now, continuing on, suggestions to improve delivery time. So, what I try to do, I focus on delivery time because there was a negative 0.7 correlation, a strong correlation between delivery time and customer satisfaction. So I try to find ways to lower that delivery time. And one of the things is to look into product category. If you look at product category here, it seems that in the orange, the get order time, the time it takes from to getting the order online and picking up on the store, it's equal for all product types. However, the one that we should take a look into is groceries, because groceries tend to have the shortest average delivery times. And let's look at traffic density. So there's what I've done is I compiled some results here. I plotted it. And if you look here, for instance, there seems to be a relationship between the vehicle type and the delivery time here. If you look at here, there's noted it's grouped bar charts. All the traffic types are listed here: low, medium, high, and jam. And this makes sense. Lowest traffic density means lowest delivery time. Jam is the highest. And continually, what we see here is that the mean delivery time for motorcycles, irregardless of the traffic density, has a higher average delivery time, which seems to indicate that yes, motorcycles might be the cause. The hypothesis I thought of was maybe they need extra time to lock up the motorcycles to make the deliveries, but that's up that we need to investigate to find out for sure. Now, this is very significant because out of all the vehicle types, the motorcycle is the most common type. So, if indeed motorcycles are the vehicles that are slowing down delivery times, it could be a wise choice to move over from the motorcycles, lower the number of motorcycles, and move on to get more scooters and vans instead. Now, traffic, I've looked into the importance of traffic. This is important because about 32.13% and 10.03, so rough, slightly less than half, are in very high levels of traffic areas. So, another suggestion that I can make here is that we need to avoid high traffic areas. Of course, that I'm just saying the results here. It's quite significant finding. In terms of finding solutions, we'll have to rely on the logistics teams to do so. Now, another thing I've looked into is, do area types of the city make a difference in terms of delivery times? And then the answer is a sounding yes. Visually speaking, here, look at here, there are different types of areas: urban areas, metropolitan, other. Like urban areas would be dense, right? I would have thought people would assume that urban areas would take longest, but no, that was not the case. It was actually semi-urban in this case that caused the highest average delivery times. So does weather have impacted delivery times? And the answer is yes. Funny thing, you would think good weather would cause less traffic. That's not the case. The weather conditions that cause a lower traffic densities would be the bad weather types, such as cloudy and fog. So that's another suggestion that could be made here. That conclude off, I have played around with GIS. I never did GIS before, but this is the first time doing it. I had a difficult time, but what I initially wanted to do was like Google Maps, right? Like for instance, start and end destination. But I found that it's last mile, and it was not practical. I'd say I have to look at it route by route, for instance. But I just did this sake for generalities. This one was particularly fun to do because initially I tried to do all the data points, but I realized the computer was continually crashing. So I found a alternative, and it's called Mark Cluster. by clustering the data, you don't need it's not as intense on the computer, I guess. So I was able to pinpoint this. It made sense here because like Mumbai would be considered a very dense city. So I noticed like all the data points are located within cities here. So this geographic data made absolute sense to me. An anomaly I had was that some of the data points were here in the ocean. Now I don't know if they're actual islands, but uh, in terms of the numbers, you see that's 154 compared to 39,000. So if this didn't make sense, we could make a subset of data and just focus on this country of India, for instance. Another thing I did is heat maps. This gives you, in terms of deliveries made, where are many of the deliveries made, and you can see that I mentioned prior, like Mumbai, for instance, like those areas here are the areas that makes a lot of deliveries, and areas here in the east not as much, for instance. So this is something that could be derived from like visualizations. Now, finally, to conclude, I had some suggestions. So the objective was to increase customer service, which I implied making betterments in agent ratings, right? And there was a high correlation with delivery time. So I focused on lowering delivery times, for instance. And this is the suggestions I had to lower delivery times in a business case, for instance. Number one, we found that younger drivers tend to deliver faster than other older drivers. Now, I cannot make this conclusion for sure yet because, like I said before, maybe the distance, maybe the older drivers would undertake more difficult or longer routes than younger ones, for instance. So we'll have to investigate to make a full conclusion. We can't conclude just yet, but this is the observation that we have so far. Another thing that seems to impact delivery times is time order. So there's no difference in terms of product category types when it comes to the time the order was made online and picked up in stores. However, there was an impact on delivery times from the store to final destination. And in this case, we found that groceries were the shortest ones for some odd reasons. So if the business was to expand here, it would make sense to focus on groceries, for instance, or like say Uber Eats, right, or food deliveries. That could increase making more deliveries and increase agent ratings as well. Number three, Gulosh. Oh, fast. I repeated three as well. But number four, motorcycles seem to be the slowest method of transportation, regardless of traffic density levels, and they're the most used. So this is very significant. So the suggestion I would say is try different vehicle methods such as scooters or vans and see if that can make a difference. Number five is that jam and high level traffic significantly increase delivery times. So finding alternate routes or making deliveries when the traffic levels is low would definitely it makes logical sense to make faster deliveries. Out of all areas, semi-urban seem to be slower delivery times. So um, uh, not so this might be something that we could look into. We'll have to investigate further. And lastly, bad weather seems to decrease delivery times. So conversely, I guess this is the reason that maybe a lot of cars would avoid bad weather, and that would give the opportunities for delivery drivers to take the road instead. But anywho, this is the summary of all the findings and suggestions that I made based on the findings that I had. And this was possible because I cleaned the data and I made analysis on it. So remember initially there was a spreadsheet. I don't think that would have been possible based on just numbers and letters, but making insightful conclusions, making insightful kind of details, finding out things enabled me to have more confidence in making these suggestions. And I guess that's a point here. So uh, I hope that helped out everyone here today. Again, you could take a look at my Kaggle notebook to see the code for your own convenience. And if this was helpful, I would suggest that you leave a like on the Kaggle page as well, and that will motivate me to do more projects like this one.